Fun with marshmallows! Time to celebrate, everybody, and clean the glasses off. It is episode 100! Yes! We made it! So then we're going to say graduation. So, we've made it! Oh, there you are. Okay, we actually are recording. I can't see anything. Oh, hey marshmallows. Okay, today is going to be a little bit of a kind of review and sum it all up thing. It's kind of appropriate for lesson 100. We're going to be solving quadratic equations by graphing. We've been doing all kinds of things with quadratic equations. We've been learning about factoring and finding key points and doing stuff by hand and all this kinds of stuff. I actually was looking back and I was like, well, you can't really see that. Lesson 84 and lesson 87 and lab 8 and lesson 89 and 96 and 98. We've all been kind of leading up to this whole let's sum it all up kind of business. So we'll talk about zeros, and we're going to talk about like things we can find before we go ahead and graph it. That all will pretty much be review. And then we'll look at graphing it on the graphing calculator rather than by hand and on graph paper. So we're going to put all this mess together here, and then off we go. I'm not going to eat those. It's so gross. Okay, so let's talk about this stuff right here. Here's a bunch of things that we can, they say, like, here's the steps to go through when you want to find a bunch of the points so that you can graph stuff. And put a graph deal here. And the first thing we would want to find would be the axis of symmetry. That can be found, it's an X line, it's dotted, it's vertical. It's a place where the picture looks the same on the left as it does on the right. And if you're using the standard form of a function, a quadratic function, ax squared plus bx plus c, you're going to take out the b number and you're going to take out the a number and throw it in to that formula, and you'll get yourself a dotted line, symmetrical line. The vertex, well, the vertex is on that line. It's either the highest point or the lowest point, depending on whether your graph opens up or if it opens down. Here we're looking at the a value. If the a value here in our standard form is a positive number, then this thing opens up and our vertex is a minimum. If a is a negative, right there, that means that the parabola will open down and that vertex will be a maximum value. When we go to find the vertex, we're going to use this point right here. And then we're going to plug it into the function, our parabola function. And we'll get the y value for that. There's also another form of quadratics, and it's called the vertex form. And your vertex is hk. So sometimes we rewrite these ones when we factor, and it makes it really easy to pick out what it is that they did to place that vertex there. Anyway, let's imagine the vertex is right there. Then we want to find the y-intercept. That is, when this thing comes across this way, we want to know what that value is right there. And we already learned that the y-intercept is at C. That is that right there. Oh yeah. So if we turn the equation into 0 something, we plug in a 0 in for x, 0, that part becomes 0. We're left with this part, and that is when when x equals 0, we're on the y-axis, and that's another important point. So we've got an axis of symmetry. We've got this. We can find another point over here that is symmetrical to that point right there. That could be another point we would use. But as for two other points, which might be the zeros, or it could be something that's the same distance away from our axis of symmetry as the y-intercept, Or we can just plug in two different numbers into the formula, that is this formula. So maybe we wanted to pick a -1 and a +5. Doesn't matter, we can plug in any other 2 points, and out comes a y value that goes along with that x value, and we plot those points, and then we basically connect all these dots that we have acquired. You can also plug this into your calculator, into your y equals, and then go second graph to make a table, and it will give you a whole bunch of points, and you can plop them on a graph and then connect the dots. So that should all be a review. We're looking for an axis of symmetry, a minimum or maximum point, our vertex. We're looking for a y-intercept, maybe a couple other points. We get all those points on the graph. We connect the dots in a smooth, curvy parabola shape, and yay, we celebrate. We just label all our stuff on our graph, and we are done. Now, we've been doing factoring. We want to break one of these types of equations down into something like this. And then we use the zero product rule to figure out what the x values happen to be. And then we related that to the number of zeros that that equation had. So if we can break it down like this, we know we've got two things that make this equation equal 0. We may have a situation like this, where it's just x plus 2, so we get the same answer twice. Or we may have something yucky. I'm trying to think of a situation where that would be the case. Oh yeah, where our equation is something like this, or x squared plus 4 equals 0. There's really no good way to solve that one. Well, there's one good way. Yeah. But we'll be stuck for now until you get to lesson like 60-something in Algebra 2. What we find is that the number of zeros, or the number of things that finish off that problem equals 0, correspond to the number of times that the picture of the parabola, picture of the quadratic function, crosses the x-axis or touches the x-axis. So we get something like x squared plus 4 that does never do it, or x squared that hits it just once equals 0, or x squared minus 4 equals 0 that crosses it twice. Okay, that's kind of important. We can do it algebraically if we're in one of these two situations, and we can't do it algebraically yet if we've got this situation. But we can always graph the picture and use our graphing calculator capabilities to find lots of the points that we want. All right, so that's all the classifying of everything that we could possibly ever need all in one place. Let's take some examples, and I'll throw a few up here, and then I'll do a couple on the graphing calculator just to top things off. The first one that I have in the book is dealing with this problem right here. And instead of this being a function like either y equals, like what we put in our graphing calculator, or function notation, what we're doing here is we're solving. We're solving. That means we're looking for where we're at y equals 0, or where this equation equals 0. On the graph, we're talking about the x-axis. We're talking about what points on the parabola cross the x-axis. So we add this equals 0 business, either on this side or on this side. If that makes you happy, then go ahead and do that. What we get is a little math problem that we have to figure out. And we'll go something like this. Add 36 to both sides, and then take the square roots. We get our answers. Graphically, what does that look like then? Well, it means that at -6 and at +6, this thing crosses the axis. It opens up because The number in front of x squared is a positive number. It's a positive 1. So we know that this is going to open up. And then if we want to know the vertex, it's right in the middle. And the vertex is C. If we were going to do this in standard form, we'd have like a plus 0x. So C is right there. It will cross way, way down here at negative 36. And honestly, that is enough information there to draw a picture. And it doesn't necessarily have to be a scale. It just has to accurately represent the key points that we have. So we got a vertex down here at 0, negative 36. It's also our minimum point. It is our y-intercept as well. And then there's two other points, the zeros. That one's pretty straightforward, yeah? Okay, another one that they put there for as an example in the book would be negative x squared minus 2. We'll plug in our equals 0. We can think of it in terms of a's, b's, and c's here in standard form. The a is negative 1, which means this thing opens down. B, it doesn't have a b part. There's no x all by itself, and c is negative 2. We could go ahead and find an axis of symmetry at negative 0 over 2 times negative 1, which is at, well, that's just equal to 0, right? So we get axis of symmetry at 0, right down the center, dot, 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 dot. The vertex is when we plug in a 0 into the equation. That would be at 0, comma, right here, negative 0 squared minus 2. 0, negative 2. There's our vertex. It opens down, we said. Maybe we want a couple of other points. Well, that's fine. We could plug into this equation. Maybe we want to plug in a negative 1 and a positive 1. F of negative 1, F of positive 1. Negative 1 squared minus 2 equals negative 1 minus 2 is negative 3. Okay, that's right there. And if we do this one, we'll go negative positive 1 squared minus 2 also equals negative 3. And there's another point for us. We've got everything that we need, and we've drawn a picture. We can label these parts, and there you go. That's pretty much all you need. Now, they give some other ones in the book, and they look a little messed up. I'll just show you the equations here really quickly. They got one that says x squared plus 16 equals 8x. And I'll put one more. Negative 6x minus 9 equals x squared. Really, on both of these, you just need to clean it up a little bit. And the way we're going to do that is we're just going to put all the terms on one side and say equals 0 on the other. Then we can graph it. And that 8x needs to move over here. So this becomes 8 x squared minus 8x plus 16 equals 0. And we've got a 1 for A, a negative 8 for B, and a 16 for C. Where we can go ahead and do these things with it to get our shape. Opens up. We can figure out where it crosses. We can figure out its intercepts, its vertex, axis of symmetry, all that. This one here, we can move everything to the right or to the left. It doesn't matter. If we move everything over this way, we'll get plus 6x plus 9 equals 0. And then we can graph that one. It will open up. But we just have to rearrange a little bit before we go ahead and do any of the graphing. Okay, again, A is 1, B is 6, C is 9. We use these things. We find enough points. We draw a picture, and then we carry on. Okay, I'm going to give a second video. We'll go over just a few of these very same ones. Maybe you want to try it by hand. And then we're going to try it on the calculator and see if the pictures match. And now we can use the calculator to find all those key points that we might want. So tune in for the next episode here, finishing off lesson 100.